So we are solving the question minimizing the heights. Minimizing the heights. So in this question we have given an array, like the array is suppose 1, 5, 8, 10, and we have given size of the array, which is 4 in this case, and we have given a variable k. So what the question says is we have to modify the each value in the array represent the height of the tower, first 1 represent the height of the first tower, 5 represent the height of the second tower, 8 represent the height of the third tower, and 10 represent the height of the fourth tower. So what we have to do is, so in this question it's saying ki we have to modifying the height of the tower by increasing k or decreasing k. We can do, we can increasing the array like 1 plus 3, 5 plus 3, 8 plus 3, and 10 plus 3. Or we can do 1 minus 3, 5 minus 3, 8 minus 3, and 10 minus 3. We can do both operation. We can increase the height by k or we can decrease the height by k. So what the question says ki after increasing or decreasing, so what this become 4, 8, 11, and 13. And what this become minus 2, 2, 5, and 7. Yeah. So what this saying is you have to find the height of the maximum minimum. So height is minimum is this and maximum is this. So height is 13 minus 4, which is 9, and height is minimum is minus 2 and maximum is this. So height, the difference between minimum and maximum is 9. No, I think this is minus 2 now. Yes, so difference is 5. Yeah. So also this is saying, yeah, so also this is saying the height of the tower can be negative. So in this question there are two there are two parts of this question. In the first part is saying the height of the tower is negative, and the other part is saying height is non-negative. Height is non-negative. So yeah, so what we have to do is find the height. So for our array is 1, 5, 8, 10. So we can do add 3 to it, k is 3 na, k is something 3. So if we add 1 plus 3 is 4, let's subtract 2, let's subtract 5, let's subtract 7. So difference is minimum and maximum is 5. And yeah, or other thing what we can do is yeah, or what we can do, let's add 4 or subtract maybe not subtract, it's 8. Yeah, it's 8, let's see is 5, and let's say 7. Yeah. So what's the difference between minimum is 5, maximum is 8, its difference is 4. So now other things you can try and you can get the 4, because all the combination and you get the answer is 4. So what the approach we can do to solve this problem and what we can do. So what I am saying is difference is b minus a. So what I'm saying is if it goes to what can I do? If I add k elements to the every elements, then this is a plus k, this is something in the middle plus k, and in the last b plus k. Then what the difference? B plus k minus a minus k. So b minus a. So after adding something to the elements, the difference not change. Same case with the different it's a minus k and b minus k. Then also it's b minus a. And other case we can take is its increment in the, and decrement in the b, then difference is b minus k minus a minus k, which is b minus 2k. And the other case is a minus k and it's b minus k. So b plus k, then difference is b plus k minus a minus k, which is b minus a. It's b plus k, a minus k plus k plus 2k. So different the distance is increases, and that's we not want, because in this case difference is reduced, this approaching this side, but in this case this is gone there and this is gone there and the difference is increased by 2k, but in this case increased by 2k. So this is the observation we have made. What we have to do is we have to first pointer to the left side, and in the last value of the array we have to go right side. Yes, by k times. Yeah, so this is observation we have. Now so we have say like this is a, this is b, then we have to go this side, this is go this side. Now what I am saying is either these two is the answer or in the middle, like if there is c and d, then this should be also be answer, like d minus c is also be answer. Like if there is something, then this can also be my answer. Yeah, so now the code part. So we have given a minimum difference, a function minimum difference, and the function include a array, the size of the array, and the value of k. So what first we have to do, we have to sort the array. So sort arr plus n, or if it is vector, then what we can do is sort like if vector, then we can say v dot begin, v dot end. Yeah, or this is time complexity is big of log n of the sorting function if you use quick sort and log n. Yeah, and now I am saying is minimum value is what, arr of 0 is the minimum value. Yeah, and maximum value is arr of n minus 1. Yeah, this is the maximum value. Now I am saying is difference is arr of n minus 1 and minus 1 minus of arr of 0. Yeah, this is the difference in the last one and the last one. So this is the difference. This can be my answer. Also, this is not true that this cannot be my answer. This can be my answer, and between the last one, if there is something, then this can also be my answer. So what I am doing is now this can be my answer. Now what I am saying is I am taking a loop, like in the question 8, 10. Yeah, I am taking a loop from 0 for in I equal to 0, I less than n minus 1, I plus plus. Yeah, so you know, now you have one question like why you not include n minus 1. So the reason is we have not include n minus 1 because we have taken n minus 1 already here. We have taken n minus 1 already here. So yeah, difference. Okay, so what I am saying is, okay, so now we have to find current minimum and current maximum. So I am initializing two variables, current max and current min. Yeah, so what I am saying is current max. तो current max क्या होगा? तो current max is maximum of, what is maximum of? So so we have to go move. For finding the maximum, we have to go this side and increment by k. So increment by k. So this is arr of I, arr of 0 plus k, arr of 1 plus k, arr of 2 plus k till arr of n minus 2 minus k. We have not include last part because if we include last part, if we include, like I am saying is, if we include arr of n minus 1 plus k, then you don't need to include that part now. Why? Because this is n minus 1 and we have to go in the left side. That's why we are decrementing k, because we have to decrement that side. If we include that side, there's no sense of including that part now. So we have to go left side, not include that part. So arr of I plus k, we are going in the right direction and including, and also we have to check if these are maximum or the last one is maximum. If we find there is maximum between these two, not last one, arr of n minus 1, then what we can say, these are the maximum. if if we can't find max greater than this, then we can say this is the maximum. So what this is, ARR of, this is maxi ARR of n minus 1, or what we are doing is subtracting k, we are going in left side, and this is we are going in right side. So this is the, okay, and current minim equal to min of, what is min of, so min of what, minimum is this a and b, so minimum is this, we have to go in that direction, but we are not including this. Why we are not including this? Because this is ARR 0 and we have to move on the right side, that's why we are ARR 0 plus k. So ARR of plus k, and if we find minimum than this, then the minimum change to this. So what this is, ARR of I is 0, so I plus 1 in the next element till I plus 1, and what we are doing is find minimum, so reducing k. That's and now the difference is what, difference is minimum of either this is the answer or this is the answer. Between these two, this thing is the answer. So what I'm saying is either difference is the answer, or either current maximum minus current minimum is the answer. Okay, now this is done, and now that's done. And in the last, what we did is return difference, and this is the code, we have written for these are. So first we have short it, then we initialize mini to in the first, and then what we have done is initializing minimum, we have find minimum this, maximum this, then find the difference between these two, and then store in the difference, because this is the answer. Then we iterated loop till here to here, this is n minus 1, and this is 0 till 0 to n minus 2, we have iterated loop. Then we find maximum between these and this, and we have find minimum between this and these, and then we find difference, if this is the answer or between these two is the answer, and then return difference. So by doing this, you have solved the question, minimize the heights. And there is second part, minimize the height, where we can't take negative. So what I'm saying is, if we can't take negative, then what we can change in the code is, what's the problem? If we can't take negative, then this is positive, this can't be problem, this is error n minus 1 minus k. Either this, if this is negative, then this might be positive, so this can balance, but this is also positive, but this can be a problem. ARR of I plus 1 minus k, ARR of I plus 1 minus k, this can't be a problem. So what I am saying is, you can do this thing if ARR of I plus 1 greater than equal to k, then you can do these operations. Then this will successfully then this code successfully run for minimize the height part 2. And thank you.
So hi guys, welcome back to the channel, and we are solving the question minimize the heights one. So in this question we are giving a array and heights of n towers and the positive integers k. We have to modify, either we can increase the heights by k or we can decrease the height by k. We have to find the worst possible difference in the heights of the shortest and longest tower of modified tower. So we can modify, we can increase 2 in this, so is 3, 7, 10 and 12, and then we can find difference between minimum and maximum, which is 3 and 12, which is nothing but 9. So we can increase this 3 and we decrease this 2, 8, 3 and difference is 5. So this is the minimum difference you could get. That's why its answer is 5. So in this question, what I am doing is, we have to find difference, so we can find the difference between these two. So I'm saying is, if we want to find difference, then we can short the array to get short. Now why we are using the short? So if we use the short, then we can show that all the minimum values in the left side of the array and the maximum values of the right side of the array. So we can say its difference is outermost element minus starting element of the array. So difference is, we have to maximize this difference. So maximize the minimize this. So we have to minimize this. So Now I am running a loop till 0 to -1 plus. Why I am not using n -1? Because what we have to do is we have to minimize the difference. So starting element in this position, left side of the array, and the maximum is the right side of the array. We have to move left side of the element to the right side of the element, and right side of the element to left side of the element, so that the difference these two can be shrink. So what I'm doing is the left element is nothing but here at 0, which is the leftmost element. We have to increase by k to minimize the difference, and right side is nothing but error of n minus k, and we have to decrease by k to move on the left side. So yeah, now also I am initializing two variables, current min and current max. Yeah, so current min is nothing but minimum of minimum of what, minimum of left, we have to left, and ARR of we have taken ARR, so ARR I plus 1 minus k we have to decrease. We have to take difference between these two so that it can be minimized. So ARR I plus 1 minus k, and current max is nothing but max of right ARR of I plus k. Take ARR 0 plus k till ARR of and minus 2 plus k, and we have to find difference, so we have to minimize the difference. So difference is nothing but minimum of max, minimum of difference, and current max minus difference between these two, and we have to find the difference. Yeah, let's check it out. It's running perfectly. And the problem solved successfully. Here is a slight modification of the problem. So what I'm doing is I'm copying the code, and the modified version, the same problem is there, but and this question is saying after this operation the resistance should not contain negative integers, so it can't contain negative integers. So what we will do, the problem is negative is this, this thing gives us a problem, because error I plus 1 minus k can be negative, because we are subtracting k from it. If k is max than error I plus 1, then it can be negative. So take care of this. I'm saying if error of I plus 1 greater than k, then run this. Yeah, I think it's greater than equal to k, but let's see. Yeah, it's greater than equal to k, because we can also include 0 now, because it's not saying we can't include 0. Yeah, so problem solved successfully. Thank you. And one thing, the time complexity is big of n log n of shorting function. Then we are this is variable, so no space use. This big of n minus 1 is the time complexity big of, and the time complexity of this for loop is big of n minus 1, big of n log n, and big of n log n. So n log n plus n is nothing but n log n, so time complexity big of n log n.